Okay, now we are going to see how to find the angle between two lines, angle between two planes, and also angle between line and plane. So here there is a typo there. This one should be line. Okay, so there are three things: line, line, plane, plane, line, plane. Okay, so let's see this one here. So bring us back to the first second subtopic, actually, your dot product, which is you have already seen how to find the angle between two vectors. Okay, so it is exactly the same thing here. So let this one here be as our line 1 and this is our line 2. So obviously our line has a vector. Okay, so this is our vector 1 and here is our vector 2. Okay, and this is the angle that we want to find. So exactly the same thing as the dot product, which is we are going to use the formula cos theta equals to v1 dot v2 over by magnitude of v1 times magnitude of v2. Okay, so now what we have to do is just substitute everything inside the equation and make sure your calculator is in degree. Okay, so instead just any other vectors, we are going to use vector for the line here. Okay, so let's see here. Example 26. The vector equation of two straight lines are given by P. This is one line and this is the other line. Okay, so let's put this as line 1 and this as line 2. Okay, so what we know from this, the question asks to find the acute angle. Okay, acute angle between these two straight lines. So what we have is we have the formula theta equals to inverse cos v1 dot v2 over magnitude of v1 and v2. So let's label. So we need the vector here. So we have v1, which is, you know that this is your r equals to a plus tv. So this one on the back here is your v. So for v1 is equals to I plus 3j minus 3k, and our v2 is equals to I plus 2j minus 4k. Okay, so to use the formula for angle between two lines, we have theta equals to inverse cos. You know that line has a vector, so here's supposed to be v1 dot v2 over magnitude of v1 magnitude of v2. Okay, so we are going to substitute everything inside this formula. Let's find this first, v1 dot v2. Let's find the dot product between the two vector. v1 dot v2, we have v1 is equals to 1 3 negative 3 and v2 is equals to 1 2 negative 4. So here we have 1 plus 6 plus 12, which is we have 19 here. And we want to find the magnitude of v1, which is square root of 1 square plus 3 square plus negative 3 square, which is here we have square root of 19. And for magnitude of v2 equals to square root of 1 square plus 2 square plus negative 4 square, which is here we have square root of 21. Okay, so substitute everything inside this formula here. We should have inverse cos of v1 dot v2, which is we have 19 over square root 21, square root 19, square root 21. Okay, so substitute everything inside your calculator. You should get the answer 17.98 degree. Okay, remember vector always in degree. Okay, not in radian. So as easy, as simple as that. So let's try one more example here. Find the angle between two straight line. This is like exactly the same thing. So we have theta is equals to inverse cos. Now let's just put everything inside here. The dot product, so from line 1 this is your v1, from line 2 this is your v2. So we have negative 1 1 2 dot with 3 negative 2 negative 3 divided by the magnitude, square root negative 1 square plus 1 square plus 2 square, and here we have 3 square plus negative 2 square plus negative 3 squared. Okay, so here you should have cos inverse cos negative 11 over square root 6 square root 22, and you have the final answer 163.22. Okay, so that's it. That is the angle between two lines. You just need the vectors, okay, for the line here. So let's see how to find the angle between two planes. Okay, angle between two planes. Let's just erase that. Okay, so you know that if you have a plane, you need a normal. Okay, so exactly the same formula, but you are going to replace the vector with the normal. Okay, exactly the same formula, but we are going to replace the normal, the vector that we have here for angle between two lines, with the normal. Okay, so now let's just go straight to the question here. Find the angle. So the angle between two planes is like this. Okay, you have one plane here. Let's see, ambil kertas A4, take one A4 paper, you take another one A4 paper, you put just on top of that paper, and there's going to be an angle, okay, between those two papers. So that is what we have to find. So let's see, find the angle between two planes. 3x minus 2y plus 5z equals to 1, and 4x plus 2y minus z equals to 4. Okay, so let's put this as P1, this as P2. So we know that the normal one is equals to 3i minus 2j plus 5k, and normal 2 is equals to 4i plus 2j minus k. Okay, so now just substitute everything in the formula. Theta is equals to cos inverse cos, exactly the same thing as before. Just now we are for now we are using the normal for the plane. So here we have 3 negative to 5 dot with 4 to negative 1 divided by the magnitude of those two things. We have 3 square plus negative 2 square plus 5 square, and this one here we have 4 square plus 2 square plus negative 1 square, and we should have inverse cos. The dot product 12 minus 4 minus 5 will have 11, right? Okay, and here we have 9 plus 4 plus 25. Sorry, here should be 3. Okay, so here should be 3, and this one here should be square root 38, and this one here should be square root 21. And put everything inside your calculator. Make sure your calculator in degree. You get 83.9 degree. Okay, so easy. So now this one is just the same. You can just do it by yourself. I'll give you your final answer, 53.99 degree. Okay, so now let's see for this question. Find the acute angle. So keyword is the acute angle. Remember, acute angle always less than 90 degree. Okay, so now we have the two normals. Okay, we want to find the theta inverse cos. So the two normal here is 151 dot with 2 negative 1 2. Okay, divided by the magnitude, square root 1 square plus 5 square plus 1 square, square root of 2 square plus negative 1 square plus 2 square. And here we have inverse cos. The dot product should be 2 minus 5 plus 2. We have negative 1 divided by square root 27 square root 9. Okay, so now you get the answer 94.68. But remember, the question said find the acute angle. Acute angle has to be less than 90 degree. Okay, why do we get the not acute angle? So as you can see, if we have a plane and we have another plane here, okay, you know that this is the angle that we want to find. Okay, this is actually the acute angle. So this angle that we find is more than that. Okay, so what we have to do here is to find the acute angle. It's just basically we have to subtract from 180 degree. Okay, 180 degree minus 94.68, then we get 86.3 32 degree. So that is your acute angle. Okay, so as easy as that, the same formula but now using normal. Okay, now let's see how to find the angle between a line and a plane. Okay, so by now you should know how to find the angle between line, angle between line and plane. So let's see. We have a diagram here. So okay, so this is your line. Okay, this is the line that we want to find. Okay, and this is our plane. So the angle that we want to find here is this angle here. Okay, this is the angle that we want to find, theta. Okay, but how can we find theta here? So we know that the equation for line is L1 R is equals to A plus dV, and the plane here is R dot N is equals to A dot N. So now for line we know that we have to use cos. For plane we have to use cos. The same thing happens here, we have to use cos. But now if we find the angle between line and plane, okay, remember for line and line we have to use the vectors. Okay, vectors of line. For plane we have to use the normal. So normal to the plane is this one here. Okay, this is normal to the plane, perpendicular to the plane here. So if we use the formula, cos theta is equals to normal dot by the vector over by magnitude of normal, magnitude of vector, because we are finding the angle between line and plane. What angle is this actually? Okay, this is not theta, this is normal, this is vector as your plane. Okay, this is vector. So the angle that you find here is actually this part here. Let's label that as beta. So this is not theta, this is actually beta. So how to find theta here? So the alternate angle, this is your alternate angle. This angle is just the same as this angle here. So this is beta. Okay, so to find theta, okay, so to find theta, we just basically have 90 degree here minus by beta. So to find theta is equals to 90 degree minus by beta. So that is how we find the angle between line and plane. Okay, the same thing as before. Line we use vector, plane we use normal, plane we use normal and vector, but there is extra working here, which is you have to do 90 minus by beta there. Okay, so let's see the example here. Find angle between line and plane. Sorry, find the angle between line which is parallel to the vector 2i minus j. So there we know that the vector is equals to 2i minus j, and plane are 3i plus 4k equals to 5. So we know that this is the normal. Okay, so this is the normal for the plane, 3i plus 4k. Okay, so let's substitute into the formula. So you know that here we have a plane, here we have a plane, and we have a line here. Okay, this is our line which is in direction vector here. So which is we have the normal of the plane, here, but the angle that we want to find is here, theta. Okay, but if we use the formula cos theta, cos something equals to n dot v over magnitude of n, magnitude of v, we are going to get this angle here. Okay, because we use normal and vectors, so this angle is actually beta. Okay, so cos beta. Okay, so now we just substitute everything. We have the normal as 3i plus 4k, so there is no j, so that means 304 dot by the vectors we have 2, -1, 0 over square root of 9, 3 square plus 4 square, and here we have square root of 2 square plus negative 1 squared. Okay, so we have cos beta is equals to the dot product. Here we have 6 plus 0 plus 0, so that's going to be 6 over by square root 16 plus 9 is 25. 4 plus 1, we have 5 here. Okay, so just substitute into your calculator. We have cos inverse of this thing here. You should get the answer 57.54, but that is not the answer. Okay, that is the angle between normal and the vector. We want to find the angle between the plane, okay, this plane here, and the vector and the line. So what you have to do to find theta is equals to 90 degree minus 57.54, which is we end up with 32.46 degree. Okay, so it almost the same thing but a little bit different. You have to subtract by 90. Okay, so let's do this one more time. Find the angle between straight line and the plane. So we just use the same method, the same formula, but this one is beta. So cos beta is equals to, so your normal of the plane is this one here, 1, 1, negative 3. Your vector of a plane is, this one is r equals to a plus tv. So this is your v for 0, 1. Divided by the magnitude, we have 1 plus 1 plus 9, and here we have 16 plus 1. Okay, so to find the beta here, we have inverse cos up 4 plus 0 minus 3. So we have 1 here, divided by square root 17 square root 11, which we get the answer 85.81. Okay, but remember that is not the final answer. We want to find the angle between plane and the line, so we have to find theta equals to 90 degree minus 85.81, which is we get the answer 4.19 degree. Okay, so that's it. That is how we find the angle between line, plane, line, plane. Okay, let's do a little recap here. Between line is theta equals to inverse cos. Remember, line has a vector, so we have to use vector 1 dot vector 2 over by magnitude vector 1 magnitude vector 2. Okay, plane, angle between plane. So you know that angle plane has a normal, so we just use normal here. Normal 1, normal 2, magnitude normal 1, magnitude normal 2. And if the question asks to find the angle between line and plane, what we have to do is exactly the same. So we know that plane has a normal. Let's just put normal. We know that the line has a vector, so we put vector. Divide that by the magnitude. Okay, so but remember, this is not theta. Okay, this is beta. So extra work here, we have to do theta equals to 90 degree minus by beta. Okay, so that is a recap for angle that we have to find. Okay.